So now let's see how easy it is to implement this use case with Octave Cloud Actions. So let's have a look. I have a first tab here where I have access to the device that I'm using for tests. So it has streams in which the default stream in which the location is reported every minute in this case. And if we look at the command stream, since the cloud action is already in place, we can see that there are some commands sent from time to time to indicate that the weather forecast that needs to be displayed has changed. Let's just have a quick look at the device summary page. So here we have the device name that will be used by the cloud action to identify the device. And as you recall, we have used tags to indicate which devices need to be taken into account by the cloud action, and this is where tags can be seen and configured from. Then the other part that we'll be using is the one stream on the cloud side where the weather updates are kept and known for each device. So you can see that it has stored weather information for 3 devices. So we see the weather forecast itself, and one key element that we'll be using is the hash that allows to identify in a unique fashion which device the event corresponds to. And here I have a hash corresponding to the Mango Red 1 device which I'm using, but I also have some Mango Red 3 and Mango Red 2 devices which have been running on this setup. Then the key panel that we'll be using to handle cloud actions is the main cloud actions panel, where you have a summary of all your cloud actions and a way to add and edit cloud actions. So the summary panel gives you the whole list of cloud actions with their name, their ID, if you need to handle them from APIs. One key element is the source of the cloud action, indicating here I have 1 and 2 cloud actions using tags and stream names to pick up information. 2 other cloud actions that are directly targeting specific streams. And the one we'll be looking at in details is this one, which is, as we saw, picking up the weather forecast tag and picking up data from the device's default stream. You also have an overview of the cloud action state, so whether they're active or not. This one that I had created earlier is deactivated. And you also have some statistics, so hourly statistics on the number of the executions for each cloud action. So you can see that I have some which are running continuously, and the one on this test device has just started running a few hours ago for today. So a convenient summary to have on all your cloud actions. Now let's look at how this cloud action has been configured. So when you create and edit a cloud action, in the top bar you have direct access to enable and disable the cloud action if you ever need to, and you have a recap of and the way to configure how to pick up the how to trigger the cloud action, either through tags as indicated here, or you can click on stream and specify the specific stream you want to trigger the cloud action from. Then I will not look at each line of code in this cloud action, but we have 4 main parts in this cloud action. The first one is the initialization. So we create some headers for the HTTP request we're going to make. We create the output variable. We're also going to pick up the data from the incoming event. So extracting the location coordinates, latitude and longitude from the incoming event, and also extract the device ID from the path item which is contained in that event. So we've got, at this stage, we've got the device name and the device coordinates. So from a functional perspective, the first key step is to make an HTTP GET to the weather forecast API. So we define a URL which dynamically includes the device latitude, longitude, and simply make a call HTTP GET to the API and parse the response just to extract the specific data we want, description of the predicted weather. And we're also just logging it. We will see that when we run the Cloud Action Simulator. The second main step is making an HTTP post to a third-party server, which is here and receives all the updates sent from the Cloud Action. And this part is once again really simple. You just have to define the payload that you're going to send. So here, sending the device ID, the device location, the device timestamp, and the predicted weather, and defining a URL to post that to. And we then just make an Octave HTTP post to that URL with the proper headers and the proper content. And that is the part which posts data to the third-party server. Then the last main part is the part where we check if we need to send a weather update to the device by querying the weather stream on the cloud side. So for that, we use the function called Octave event find hash. We're going to find an event in a given stream, so specifying the stream ID. And for that, if we come back to the Octave weather stream, which is here, you have the stream ID in the URL bar, or also if you edit here, you have the ID of the stream where you can retrieve that ID through Octave API. So we use that ID to tell the system, go and query for events in that stream, which has a hash corresponding to the device ID. And since events with a given hash are unique in a stream, it will send us the latest event and the one event that is stored for that device. So once we have retrieved that information, we just have to compare if the current weather forecast differs from the previously sent weather forecast, in which case what we do are report two things and write two items to Octave streams. One is send a command, so we construct the command path to be the company name, devices, then the device ID / command to target the device, and we're going to return the command indicating the system to display the weather forecast on line 1 of its LCD screen. And at the same time, we want to update the data that we store in the weather cloud stream. And for that, we are going just to write current weather with the device ID as a hash to make sure that we replace the stored value for that specific device. And in that, once we are in that case, we just return these two commands to output streams. In the other case, if the weather forecast has not changed, we just log that we're in this situation, but do not return anything. So don't write anything to streams.